In order to make our launch predictions, we will be using three different models that will be run using MATLAB scripts. So to start, we're in MATLAB. We open MATLAB and then open the rocketGUI.m file. Looks like this. It doesn't really matter. The important thing is once you have this open, you go up to this green arrow button and click Run. What that'll do is bring up this GUI, which will do everything you need it to do. The first thing we want to look at right here is the rocket information. We have our empty mass, fuel mass, launch angle, coefficient of drag, and bottle pressure. These are all the parameters that we will be varying. The empty mass is just the rocket the bottle rocket that you've designed. Just weigh it and put it in grams, put its mass in grams. The fuel mass is just the mass of the water. We will be using 1,000, and further in the class we will be able to, in the actual class for CU, we'll be able to change this as one of the parameters, but right now we'll just leave that at 1,000 grams. The launch angle is pretty much the same thing as the fuel mass. We're probably going to leave that at 45 degrees, but you can change that. You can mess around with it and see what kind of stuff, what kind of results happen due to you varying these parameters. Same with the bottle pressure. But the difference is right here, the coefficient of drag. We will be using wind tunnel data to get your coefficient of drag. So after you've gotten your set of data for your specific bottle rocket that you've designed, you want to go right here where it says retrieve CD from wind tunnel data. Click on that. This will bring up another GUI that will do the calculations for you. So you want to select file, find the file, the CSV file, the data file that was output from your wind tunnel test, and open it. And then you want to load data, and that'll do all your calculations for you. As you can see, our coefficient of drag is 0.28 and so on. When you click accept, it automatically puts it into the location of coefficient of drag, so you're set there. The next thing we want to look at is the environment. The environment, the temperature, pressure, X wind, Y wind, Z wind. So your temperature and pressure is stuff that you can get from, we have something in the ITL that'll give us this information. You could probably look it up online. You just want the best prediction or the best result from something that's near our location in Boulder. And then the X, Y, and Z, these are kind of an option if you want to include wind. That's the kind of thing where you'll just want to figure out the wind, its direction, and then decide what the X, Y, and Z components are due to the wind. You can select between meters a second or miles per hour. I'm pretty sure that our wind speed sensor gives us a result in miles per hour, so you'll probably want to use that. But after you have everything filled out, you'll look at the models. We have ISP, mass flow, thrust interpolation, all of which we'll talk about further in a presentation. And they're each going to give us different results based on situations. Some will be more accurate than others. We'll go more in depth about what each one is and how they are calculated. But once you have all this information ready, all you have to do is click Run Simulation, which will automatically run all of these simulations and feed you back the result and show you the plot. So once it's done calculating, it'll show you, see we have 3 plots with our legend here saying which trajectory represents which which model. And then another thing you can look at is down here in the command window of MATLAB itself, shows more specific results. You can read through this, but also the results are also shown up here in the results area of the GUI, which will just show you the distance and the maximum height of each model, which you can then use this to compare to your actual result or your actual launch results and determine which one's going to be the most accurate, or just figure out which one's best.